In this video, I'm going to introduce you to the concepts of voltage measurement and current measurement. I'm going to show you how this is done in a circuit, and my hope is that it will help you understand how to interpret the sign of a voltage or current. This is important because a lot of beginners are confused about what the sign means on a voltage or a current. So I hope this clarifies for you. So I'll start by showing you a measuring device. This is called a digital multimeter. It's digital because it displays the value on this digital screen. It's a multimeter because it can be used to measure voltage or current and other quantities. This selector in the middle allows you to select whether you're going to measure a current or a voltage, and if so, how large a quantity you'll be measuring. If we've set this to measure a voltage, we're actually using a voltmeter, so there's a voltmeter in this device. And if we set it to measure a current, then it's a ammeter. And like I said, I can choose to measure currents or voltages of various magnitudes. Another important thing to notice here is that there are two probes, a red one and a black one, and they connect to the device via these cables. And these probes have metal tips for making electrical contact with a circuit. The black one we call the reference probe and assign it a minus sign. And this red one gets assigned a plus sign. And honestly, I'm not sure that there's a generally accepted name for this. I call it the observation probe or the main probe. But whenever we measure something, it's the observation probe compared to the reference probe. And so this will come up as we get into measuring a circuit. So let's look at how that's done by considering some circuit schematics. I'll start by sketching a circuit, a very simple one. Here is a voltage source and a resistor. These wires here, so there's one and a second one, they constitute electrical connections, which we call nodes. So we'll label this one node A and node B. And we would recognize that this node, B, is 5 volts lower than A, which is a consequence of the voltage source that we put in here. So in the voltage axis, I might sketch this as A and then B, and then indicate that this is 5 volts. So here's a voltage axis. Now we also could know that 1 milliamp of current flows clockwise or down through the resistor, and that's exactly equivalent to -1 milliamps flowing counterclockwise or up through the resistor. So these are some things we know about this circuit. Now let's sketch how measurements should work here. Oh, and before we go on to that, I'm going to write a couple of things here. Knowing that A is 5 volts higher than B, we'll write that VAB is 5 volts. So I want to point out that in the double subscript notation, this B, which is the second subscript, indicates that this is the reference. And the A, which is the first subscript, is an indication of the observation point and that it's A relative to B. So A is higher than B by 5 volts. An equivalent way of saying that is that the voltage drop as you move from A to B is 5 volts. A direct consequence of this is that VBA is -5 volts. That's that B is higher than A by -5 volts. Or the voltage drop going from B to A is -5 volts. So these two statements are exactly equivalent. Now returning to our circuit schematic, the way we would measure VAB is as follows. Here's our digital multimeter. And so what we would do here is we would connect the red probe to node A, and then the black probe, which is the reference, will go to node B. And so here we're measuring VAB. So the multimeter would read 5 volts. And notice we haven't done anything to the circuit, so all the parameters are still the same. That is, we still have 1 milliamp flowing in the clockwise direction, and the voltage A to B is just as before. A is 5 volts higher. Now let's think about what would happen if we swap the position of the red and the black probes. Now our red probe will be connected somewhere, anywhere on point B. I didn't really show it connected to the circuit, but it's really indicated by this connection to the entirety of that node, because any point on B is equivalent with any other electrically. And the reference would go to node A, and because of that, now we're actually measuring VBA. So this is the voltage of node B relative to the voltage at node A. And we know that we haven't changed the circuit at all. Current still is flowing counterclockwise, and A is higher than B by 5 volts. So VBA is the answer to the question, how much higher is B than A? Well, that's negative 5 volts. So maybe going back to this diagram up here, I could put here plus, minus, this is VAB, and then on the other side it's minus plus VBA, indicating that this is the reference. Okay, so we have the same circuit in two cases, but because of the direction or the polarity of the voltage measurement, you get a negative sign. And really, that voltmeter is really just showing you the voltage difference between the observation point and the reference point. So that's what we mean when we measure a voltage, and that's how the sign comes into play. Now, let's show a current measurement. Now, this is a bit more involved. So I'll sketch the circuit again. Now I'm using an alternate sign for a voltage source. It's the same circuit, but what I've done in this case is I've introduced a circuit break. And in this state, no current can flow through the circuit, but this is necessary for a measurement of the current. So what we do is we take an ammeter, and we place it in such a way that it bridges the gap in the circuit. What happens now is that the ammeter allows current to flow. So we get the same 1 milliamp as before, but now that 1 milliamp flows into the red lead like this, through the ammeter so it can be detected, and then back out, and then through the circuit. And this is a 1 kilo ohm resistor just like before. So everything's the same, except now that we're passing the current through the ammeter for detection. And so what happens is that when positive current goes into the red terminal and out the black, you read a positive current. So this will read 1 milliamp. And we're reading the clockwise current through the circuit. So I'll just point out that what we've done here is we've placed the ammeter in the path of the current that we want to measure. So we have to force the current we want to measure through the ammeter. Now we'll ask ourselves, what happens if we reverse the leads? Here's our circuit once again, but this time we connect the leads like this. It's the same 1 milliamp that flows clockwise through the circuit, but notice that the 1 milliamp flows into the black lead and then out the red lead. In this case, our multimeter, our ammeter actually is going to read negative 1 milliamp. So drawn more simply, say if 7 milliamps enters the red lead and exits the red lead, or the black lead, then the ammeter will read 7 milliamps. But if we reverse the direction of current flow through the ammeter, so that it enters the black terminal and exits the red, then the ammeter will register negative 7 milliamps. Therefore, summing this up, let's draw the circuit again. The sign of the voltage or current reading really depends on the direction of the measurement. So for example, we know that VAB is 5 volts because A is 5 volts higher than B, and then VBA is negative 5 volts because B is negative 5 volts higher than A. And the clockwise current is 1 milliamp, and then the counterclockwise, negative 1 milliamp. So I'll just end by sketching that. Okay, so I hope that helps you understand a little bit better the measurement of voltage and current. Right, so a voltage measurement is always a measurement between 2 points, an observation point relative to a reference. And then to measure current, you have to break the circuit and you have to insert the ammeter into the circuit so that the current you want to measure passes through the ammeter. And we talked about the signs and the direction or the polarity of the measurements. I know that beginners can often find circuits very confusing, so I want you to not be confused. In fact, I want circuits to be shockingly easy for you. Thanks for watching. Please like the video, subscribe to the channel, and share it with anyone who you think this will help.